Hello students, this is the ninth video that I have prepared to explain how to use this Casio calculator using the IB Math SL question. So let us continue. So let us look at problem number 21. So let h of x equal to x minus 2 times sine of x minus 1 for x between minus 1 plus pi. This is given here, the curve. There is a minimum point at R and a maximum point at S, and the curve intersects at a comma 0, 1 comma 0, 2 comma 0, and then b comma 0. Now the question is find the exact value of a and b. Okay. Now what I'm going to do is I'm going to again deliberately make a mistake. So let me first sketch it. X minus 2. I mean, put it in the graphic display calculator. So graph bracket x minus 2 times sine of x minus 1, sine bracket x minus 1. So it is very important that you put brackets, students. Otherwise, if you don't put a bracket, then it will take sine x minus 1. Okay, so it's very important that you know where to put brackets. Now let me change the scale. So x between minus 5 and plus 5. So minus 5 and plus 5. And y between minus 7 plus 4. Okay, so draw. So I think this point is the x coordinate, this point is a comma 0 and this point is b comma 0. So g solve root. So a is minus 2.14 and b is 4.14. Okay, so minus 2.14 and 4.14. Let's look at the answers. But the answer is given as a is 1 minus pi and b is 1 plus pi. It's not minus, what is it, minus 2.14 is it? Minus 4.14 and minus 2.14. Okay, so if you write these two answers, students, minus 2.14 and 4.14, you will not get any marks. You will not get 2 marks for this question. The important thing to note is find the exact value of a and b. So this minus 2.14 and 4.14, they are actually approximate values of a and b. So they have asked you to find the exact value. So how do we do it? You have to do it like this. So x minus 2 times sine of x minus 1 equal to 0, which means sine of x minus 1 equal to 0, which means x minus 1 has to be either pi or minus pi. It can't be 2 pi, okay, because it's outside the limit. So then x has to be either 1 plus pi or 1 minus pi. Okay, so this is how you solve this problem, this particular subdivision. Okay, the next one, the regions between the curve and the x-axis are shaded for x between a and 2. So this part, write down an expression which represents the total area of the shaded region. Okay, now very simple. So you have to write two integrals. The first integral is integral a, which is minus 2.14 to 1 f of x dx, that is the expression 1. And to find the area of this part, you have to find integral 1 to 2 f of x dx and then find the absolute value, since the curve, the area lies below the x-axis. So let us look at the answer scheme. So here, this is what I said, minus 2.14 to 1 h of x dx. So let me zoom it. Yeah. So here you see minus 2.14 to 1 h of x dx plus absolute value of 1 to 2 h of x dx. So this is the expression. Now you can find this using your calculator. Okay, so you find this value and then find the absolute value, find this value, and then you can add them. You'll get 5.30 as the answer. Okay, and then okay, so the y coordinate of R is minus 0.240. Find the y coordinate of S. So S is the maximum point, the second maximum point on the right hand side of y-axis. So let me find, so g solve maximum, Yeah, the y coordinate is 0.9726, so 0.973. So the answer is 0.973. That is correct. Okay, the next one is um, hence or otherwise find the range of values of k for which the equation x minus 2 times sine of x minus 1 equal to k has four distinct solutions. Okay, I think we have dealt these kind of problems earlier. So let us say if k is 2, for example. So if I draw a line here, y equal to 2, that's f of x equal to 2, h of x equal to 2, sorry. So there are only two solutions. So if we want to have four solutions, um, then, okay, this we know that we found out the y coordinate of s is 0.973. Now if I draw a tangent at s, so that particular k value will have it will intersect, that line y equal to k will intersect at three places. But if you take a line, if you draw a line below that, below the point s, so it will cut at four places, isn't it? So four places. So again, let me find the minimum value of r, which is already given. I think it's minus 0.24. So basically, if k is anything between between r and s, actually minus 0.24 and greater than minus 0.24 and less than 0.973, k can take any of those values. That is correct. Between minus 0.240 and 0.973. I'm sorry, I can't explain further here. I don't know how many of you have really understood what I'm trying to explain here, this particular subdivision. Okay. So let us look at the next problem now. Yeah, 22nd. Solve the equation e power x equal to 5 minus 2x, giving your answer correct to four significant figures. So again, I'm going to use the graph. So delete. So I'm going to take e power y1 as e power x. So shift e power x and y2 as 5 minus 2x. So 5 minus 2 times x. So let me see the scale, shift view window, let me make it standard. Okay, you can see we can see the point of intersection, G sol intersect. So the answer is 1.05869. So since they're asking you to round it off to four significant figures, the answer should be 1.059. Okay, so let me check mark scheme. Yes, 1.059. And as I said, it is very, please make sure that you sketch like this, students, in your answer script to get full marks. Okay. Is given as C6, so even if you do not sketch the graph, you will still get the full answer as per this full mark, sorry, as per this mark scheme, but I would strongly advise against it. So always please sketch the curves like this in your answer script so that you don't leave any option for the examiners to reduce marks for you. Okay. Any chance actually to reduce, for them to reduce your marks? Okay, so let's look at the 23rd problem. $1,000 is invested at 15% per annum interest, compounded monthly. Calculate the minimum number of months required for the value of investment to exceed $3,000. Okay, so important thing is this is 15% per annum, but it is compounded monthly. Okay, so let us look at the expression. So it should be 1,000 into 1 plus 15 divided by 12. The reason is this 15% is only per annum. So to find per month, I need to divide 15 by 12 by 100 per n is greater than 3,000. So if you simplify it, you will get this expression, this inequality. So I'm going to solve this. So I'm going to take 1,000 into this part, 1.0125 per n as y1 and 3,000 as y2. So I'm going to use graph to solve this. Exit. Okay, so let us say so 1,000 multiplied by 1.0125 per n. So x, and second one is 3000. So obviously I have to change the scale. So shift v window and make it 0 to, let's say, 20. Make it as 30, and y minimum 0, maximum is, so it is, I have written 3000, so let me make it 4000. Okay, you can see that gsol intersect, it says it's not found, mainly because of the answer lies outside the domain. Okay, so shift v window, I have to make it as, let's say, 100. Now you can see both the curves intersect. So gsol intersect 88.43. So the answer is 89. Okay, so after 89 months, sorry, here the $1,000 invested at this rate of interest per annum, compounded monthly, will exceed $3,000. Okay, so let us look at the 24th problem now. The diagram below shows a sketch of the graph of the function y equal to sine of e power x for x between -1 and 2, and x is in radians. Again, this is very important. Okay, the graph cuts the y-axis at A and the x-axis at C and D, and it has a maximum point at B. So find the coordinates of A. Okay, so is it? So let me sketch this. So sine of e power x. So sine of e power x, close the bracket. Okay, the scale is x between -1 and 2. So shift window, -1 and 2. Okay, and y between, oh, is not given here. So let me make it as, let's say, -10 to +10. Okay, so let me make it as -5 to +5. Okay, I got the graph. I think the find the coordinates of A. So this is nothing but the y-intercept, gsol y-intercept. So it is actually, the coordinates are 0, 0.841. Okay, so let us check the answer. Yeah, 0, 0.841. Okay, let us keep it here. Fine. So let me change the scale. Make it as, let's say, -2 to +2. Yeah, this is better. So the next one is the coordinates of C may be written as ln k, 0. Find the exact value of k. Okay. So now, how do we do it actually? So you can't use the graph here. That means you can't say, let me find. Sorry, let me change this. Yeah, you can't say, let me go to gsolve and then root, and let us say 1.14. You can't say 1.14, 0. You have to write it in the form ln k in terms of logarithm. Okay, you have to find the exact value of k. So let us see, it's very simple. So what you do is you equate sine of e power x to 0, which means e power x has to be pi. So convert this into logarithm, x equal to ln of pi. So the value of k is pi. Okay, this part is quite simple. Now write down the y coordinate of B. So that is the maximum point. So gsol maximum, y coordinate of B is 1. Okay, y equal to 1. Let us check. Yes, that is 1. And find dy by dx. Yeah, I think this you can do it. Write down the integral which represents the shaded region. Again, that is very simple. It is 0 because it is bounded by x equal to 0 and x equal to c. So the integral is integral 0 to ln pi, this is the f of x dx, sine of e power x dx. So you can see it here, 0 to ln pi, sine of e power x dx. Okay, fine. Copy the above diagram into your answer booklet. On your diagram, sketch the graph of y equal to x cubed. Just have a look at it. Okay, so let me draw y equal to x cubed. Exit. So let's say x power 3. Done. And the last part is the two graphs intersect at the point P. Find the x coordinate of P. So that's very simple. G solve, intersect. So the x coordinate is 0.877. Let's check. Yes, 0.877. Okay, so 25th problem. In the following diagram, sketch the graphs of y equal to e power x and y equal to cos x. That's straightforward. E power x, so e power x and cos x, so cos x, it's fine. The scale is -2 to 1 and -2 to 2. Okay, -2 to 1 and -2 to 2, that's fine. Okay, so this is how it looks. It has a solution between -2 and 1. Okay, so let us look at the mark scheme first. So this is the mark scheme, and the solution between -2 and -1. So G solve, intersect. Yeah, that is the answer, -1.29, because you have to, it has to lie between -2 and -1. Okay, it has another solution. I mean, the two curves intersect at another point at 0, but that lies outside that interval -2 and -1. Okay, so that's it. Fine. So let us solve the remaining problems in the next video, students. Thanks for watching.